Imagine a country, okay, roughly the size of Arkansas, just about 800 kilometers east to west, maybe 200 north to south.
Pretty compact, yeah.
But somehow it holds this absolutely staggering range of geography and climate. I mean, from lush subtropical plains right up to the highest mountains on Earth.
It sounds almost impossible, doesn't it? But that's Nepal.
Exactly. It's like a living riddle. And today, that's what we're diving into.
Yeah.
Nepal, this place that just embodies this incredible diversity like nowhere else.
It really is a geological and climatic marvel. You're talking about one of the steepest gradients in elevation anywhere on the planet.
All squeezed into that small area.
All packed in. It really forces you to rethink what a single country can contain.
Absolutely.
Yeah.
So our mission today is to unpack that story. How does this relatively small nation manage these extremes? We're going on a journey, essentially.
From the humid lowlands.
Right, starting near sea level, all the way up past 8,800 meters. And along the way, we'll look at how these immense geological forces, the climate patterns, and, crucially, human ingenuity all weave together there.
It's that intersection that's so fascinating.
Totally. The goal isn't just, a geography lesson about Nepal. It's about finding those aha moments, about adaptation, about resilience, about how people live sustainably in these incredibly varied, often tough environments.
And maybe find some lessons that apply more broadly, too.
You might just find yourself thinking about challenges closer to home. Okay, so let's start digging into the foundations, this vertical world of Nepal.
The first thing is that extreme elevation change.
Yeah, it's mind-boggling. From as low as, 60 meters above sea level in the southern Terai Plains?
That's right, practically sea level.
All the way up to Mount Everest, Sagarmatha, and the other giants, over 8,800 meters. That's more than 8 vertical kilometers.
Packed into just a couple hundred kilometers horizontally. It's an incredible ramp.
And when you look closer, it's not just a chaotic jumble of mountains, is it? There's a structure there.
Oh, definitely. The landscape is quite clearly segmented. You can see 5 distinct physiographic zones, almost like giant layers stacked on top of each other.
Stacked layers, I like that. Each with its own feel, its own challenges.
Precisely.
So let's peel them back. Starting down south near India. What's first?
That's the Terai. It's the lowland region. Think flat, fertile, alluvial plains. It's basically part of the huge Indo-Gangetic Basin.
Flat terrain, good soil. So agriculture.
Exactly. High agricultural productivity. It's a really vital food-producing region.
Okay, move north from the Terai. What do we hit next?
Then you start climbing into the Siwalik Hills, sometimes called the Churia Hills. Geologically, these are very young, mostly sedimentary deposits.
Young means less stable.
Generally, yes. They're quite fragile, prone to erosion, landslides, debris flows, a very dynamic landscape.
Right. And then further north, higher still.
You get into the middle mountains. This is more rugged, a real mix of steep hills, but also these intermontane valleys nestled in between.
And this is where we see those incredible terraces, right?
Oh, yes. The terrace farming here is iconic. It's a defining feature of the landscape, a massive adaptation to the slopes.
It looks like artwork, but it's pure necessity and ingenuity.
It absolutely is. A constant effort against erosion, managing water on steep terrain. It allows for farming where you'd think it impossible.
And then finally, the top layers.
You reach the high mountains and then the high Himalaya. This is the roof of the world. Rock, ice, glaciers dominate. Human settlement gets very sparse up here.
And agriculture?
Extremely limited. The conditions are just too harsh, too cold, too rugged for most crops.
So this structured layering, these distinct zones, it's not random. What's the driving force behind creating this incredible landscape?
It all comes down to geology. Specifically, one of the planet's biggest geological events, the collision of the Indian tectonic plate with the Eurasian plate.
The one that's still happening, right?
Yeah. Still ongoing. It started maybe 50 million years ago, this colossal slow-motion impact. And it's basically pushed up the entire Himalayan range.
And the different zones relate to specific features of this collision.
Yes, exactly. Yeah. Think about these massive sheets of rock grinding against each other. Huge breaks or thrust faults form where one chunk of crust slides up over another.
Like geological seams.
Kind of. Key ones like the main central thrust, the main boundary thrust, the main frontal thrust, they act like demarcations, boundaries between these different physiographic zones we just talked about.
Wow. So these giant faults born from continents colliding literally define the bands across Nepal.
They really do, and it goes beyond just the shape of the land.
How so? What else do these geological processes influence?
Well, think about it. They determine where different types of rock end up, which dictates the soil types that form. They influence how water flows, where rivers carve their paths, where sediment gets deposited.
So soil fertility,
Water.
water availability.
Absolutely. And also, crucially, where natural hazards are more likely, the geology dictates landslide susceptibility, flood patterns. It shapes the resources available and the risks people face.
The ground itself tells this immense story of force and consequence.
A story millions of years in the making and still being written.
Okay, so that geological foundation sets the stage, but then there's the climate layered on top, which is just as dramatic, isn't it?
Oh, absolutely. Nepal has one of the most extreme climatic gradients you'll find anywhere. You go from basically tropical conditions in the Terai
Warm, humid.
to literally polar conditions high up in the Himalayas, all within that short north-south distance.
How many different climate types are we talking about?
Well, using standard classifications like Cup and Geiger, you can identify at least 8 primary climate types packed in there.
8. Like what?
You've got tropical savanna, warm temperate, cool temperate, subalpine, alpine, and even stretches of polar tundra and frost climates right at the top. It's an incredible spectrum.
And then the seasons overlay that.
Right. There are 4 pretty distinct seasons. Pre-monsoon, which is roughly March to May, hot and sometimes hazy. Then the main event, the summer monsoon, June to September.
That's the big one.
That's the big one. Followed by post-monsoon, October, November, often clear and pleasant. And then winter, December to February, which can be cold and dry, especially higher up.
Let's talk more about that monsoon. Feels like it's more than just a rainy season in Nepal.
It really is the lifeblood and sometimes the destructive force of the country. Those moist winds coming off the Bay of Bengal hit the Himalayas like a wall.
The mountains force the air up.
Exactly. That's called orographic forcing, or orographic lift. As the moist air rises, it cools, condenses, and dumps its moisture as rain.
Mostly on the southern slopes, then. The side facing the wind.
Precisely. The vast majority of the annual rainfall hits those southern windward slopes, which leads to a crucial consequence.
Rain shadows.
Exactly. The areas to the north, behind the main Himalayan crests and other leeward slopes, get significantly less rain. They lie in the rain shadow.
So you get these incredible contrasts. Wet areas, dry areas, close together.
Yes, and it creates this paradox. Some regions get slammed with intense short bursts of rain, triggering landslides and floods, while other areas, sometimes not far away, can suffer from prolonged drought conditions.
Climate feast or famine, you said.
That's a good way to put it. The distribution is incredibly uneven.
What about overall trends? Temperature, rainfall patterns. Is climate change hitting Nepal hard?
Well, the data shows clear spatial and temporal variability. There's definitely a warming trend observed, and interestingly, it seems to be more pronounced at higher altitudes.
The mountains are warming faster.
It appears so. The temperature increases are often greater in the high mountains than down in the Terai, and rainfall. Well, the summer monsoon is still dominant, bringing 80–85% of the annual total.
But the amounts vary hugely.
Massively. Some eastern areas might get over 2,500 millimeters a year because of that strong orographic lift. But then you go to the rain shadow zones, like parts of Mustang in the northwest, and they might get less than 300 millimeters.
Wow, that's an enormous difference.
It is. And this extreme variability, now potentially being intensified by climate change, changing monsoon timing, perhaps more intense rainfall events, it puts enormous pressure on communities. How do you adapt to that kind of unpredictability?
Which brings us right to how people actually live there, how livelihoods are shaped by this land and sky. Agriculture must be completely different across these zones.
Oh, it's a tale of totally different worlds. Down in the Terai, you have that warm, humid climate and those fertile soils we mentioned.
Ideal condition.
Pretty much. So you see intensive agriculture. Rice, wheat, maize are staples, plus cash crops like sugarcane, jute. Irrigation is key down there to support this high productivity.
But you climb up into the mid-hills, the middle mountains.
And it's a different story entirely. Agriculture becomes mostly rain-fed. And it's dominated by those incredible terraced fields carved into the hillsides.
Those engineering marks.
They really are. They're not just pretty. They're a functional adaptation to steep slopes, designed to conserve soil and manage water in a place where rainfall is less predictable. Bench terraces are a classic example, built up over generations.
So altitude dictates everything, what you grow, how you grow it.
Fundamentally, yes. In the lower, warmer, wetter subtropical zones, you see rice, which needs a lot of water. As you go higher into temperate zones, maybe 1,000, 3,000 meters, you shift to hardier crops. Wheat, maize, barley, potatoes, buckwheat, which tolerates cold better.
And right at the top, in the high Himalaya.
Agriculture becomes very marginal, very difficult. You see some hardy grains like barley, maybe some potatoes, but mostly people rely on pastoralism, herding yaks, sheep, goats, and gathering non-timber forest products. It's a subsistence existence defined by altitude.
It's not just farming, is it? Even the way people build their homes must reflect these massive environmental differences.
Absolutely. Traditional architecture is another amazing window into adaptation. It's climate-responsive design honed over centuries.
How does it differ? Say, Terai versus the high mountains.
Okay, so in the Terai and lower hills, you're dealing with heat, humidity, intense monsoon rains. So buildings often use local brick, timber, stone. Sometimes they're raised on stilts to avoid floodwaters and allow airflow. Good ventilation is key.
Makes sense. And higher up, where it's cold and snowy.
Totally different. In the high mountains, alpine zones, houses are built for warmth and snow load. You see thick walls made of stone and mud for insulation, small windows to minimize heat loss, and often steeply pitched roofs designed specifically to shed heavy snow.
So the buildings themselves tell you about the climate and the hazards.
They are a direct response. They embody centuries of understanding local conditions, thermal efficiency, and resilience against things like landslides or heavy snowfall. Living knowledge built into the walls.
And this incredible environmental tapestry, it must shape the human tapestry too, right? The cultures, the economy.
Definitely. There's a fascinating correlation between the geographic zones and ethnic diversity. Different groups have historically settled in different zones, adapting their cultures accordingly.
Can you give an example?
Sure. In the Terai, you find many groups whose cultural practices, languages, even religions show strong connections to the Indo-Aryan traditions of the Indian plains just to the south. But you go up high, into the Himalayas.
Like the Sherpa people.
Exactly. Groups like the Sherpa, Bhotia, Thakali, their cultures are deeply influenced by Tibetan Buddhism, reflecting historical links across the high passes to Tibet. You see it in their language, their religion, their dress, even their farming cycles are timed differently.
So the mountains aren't just physical barriers, they're cultural divides and bridges too.
Very much so. But this challenging terrain also leads to, well, significant economic challenges and disparities.
How does that play out?
Well, agriculture is still the backbone of the economy for a huge portion of the population. But think about access. Building roads, irrigation systems, getting goods to market. It's all incredibly difficult and expensive in the mountains.
So people in the hills and mountains might be more isolated, have fewer opportunities.
That's often the reality. It leads to big regional differences in income, in access to services, and overall quality of life. Mountain regions often struggle with persistent poverty, subsistence farming, and they're very vulnerable to climate shocks like droughts or unseasonal frosts.
Whereas the Terai, being more productive,
Has its own issues too, don't forget. While generally more productive agriculturally, it faces major problems with flooding during the monsoon and sometimes soil degradation from intensive farming. Each zone has its unique mix of opportunities and vulnerabilities.
and climate change is throwing another wrench into this already complex system.
It's intensifying existing pressures, absolutely. Rising temperatures affect crop suitability zones. Changes in monsoon patterns, maybe more erratic rainfall, intense bursts directly impact both rain-fed hill agriculture and lowland irrigation and flood risk.
Making life even harder.
It puts immense strain on traditional farming systems, on water resources, on forests. And we see the social consequences too, like increased migration from rural areas as people seek livelihoods elsewhere, changing settlement patterns. Adaptation isn't just desirable, it's becoming essential for survival.
So given all these layers of challenge, the geology, the climate extremes, the economic factors, now climate change, how is Nepal adapting? How are people building resilience? Is it all about traditional knowledge, or are new approaches coming in?
It's really a fascinating mix of both, and that combination seems to be the most effective path forward. You absolutely have to acknowledge the deep historical resilience.
The things people have been doing for centuries.
Exactly. Those terrace farming systems we talked about, they're incredible feats of soil and water conservation. Local water harvesting techniques like ponds or traditional canals are vital, especially where rainfall is unreliable. This traditional ecological knowledge is a huge asset.
But they're not just relying on the old ways?
No, there's a real effort to integrate modern initiatives as well. Things like introducing new crop varieties that are more resistant to drought or heat, developing improved, more efficient irrigation systems, especially micro-irrigation.
And using technology for information.
Yes,
Mm.
that's becoming increasingly important. Community-based weather monitoring, for example. Getting local, timely information into the hands of farmers so they can make better decisions about planting, harvesting, or managing water. It's about enhancing, not replacing, traditional resilience.
So, from a policy perspective, what does this imply for Nepal's future? How do you support adaptation across such diverse zones?
The key takeaway for policymakers is that you need spatially differentiated strategies. A single nationwide approach just won't work in a place as varied as Nepal.
Tailored solutions for each zone.
Precisely. You need adaptation plans that consider the specific climate risks, the specific geological hazards, the specific agricultural systems, the specific socioeconomic conditions of the Terai versus the mid-hills versus the high mountains.
What might that look like in practice?
It means targeted investments. Maybe better early warning systems for floods in the Terai and for landslides in the hills. It means land use planning that considers hazard risks. It means infrastructure roads, bridges built to withstand local conditions, and crucially, supporting livelihoods in ways that are sustainable for that specific environment.
It sounds like the real power lies in bringing everything together, the local knowledge and the modern science.
That's exactly it. The integration is where the magic happens. Combining, say, high-resolution climate modeling and satellite imagery that shows changing glaciers or land use.
With the on-the-ground generational knowledge of the farmers and herders who live there.
Exactly. That synergy between cutting-edge science and traditional ecological knowledge, that's seen as the most promising way to genuinely boost adaptive capacity. Making solutions that are scientifically sound and culturally appropriate that actually work for the people on the ground.
It really feels like this whole deep dive into Nepal highlights this incredibly complex, interwoven system. You can't separate the geology from the climate or the climate from the way people live and farm.
They are completely interdependent. That extreme verticality, the dynamic climate, it creates this amazing mosaic of environment. You have the productive potential of the lowlands feeding millions right alongside these incredibly challenging high-altitude zones where survival itself is an art form.
And this natural diversity, as you said, is both a gift and a challenge.
A huge blessing, yes. It supports this incredible cultural richness, unique ecosystems, but it also exposes communities to significant risks. Landslides, floods, droughts, glacial lake outburst floods, risks that are clearly being amplified by climate change now.
So Nepal's story really resonates beyond its borders, doesn't it?
Absolutely. It speaks directly to global conversations about how we adapt to climate change, how we achieve sustainable agriculture, especially in vulnerable mountain regions all over the world. It's a living laboratory for resilience.
So maybe a final thought to leave our listeners with. As we look at Nepal, it seems the future really hinges on collaboration, doesn't it?
It has to. Between the government, scientists, NGOs, international partners, and most importantly, the local communities themselves. Bridging that gap between advanced research and the lived experience on the ground is critical.
So perhaps the question for all of us thinking about Nepal is, what lessons can we draw from its unique adaptations, forged in such extreme conditions, that might help other regions facing their own escalating environmental pressures, whether it's rising sea levels or melting glaciers or increasing droughts elsewhere in the world?
It makes you think about the universality of adaptation, doesn't it?